Bismillahirrahmanirrahim. Assalamu alaikum to lecture number 14 of Software Engineering 1 CSC 291. In the previous lecture we started covering system sequence diagrams. In fact, we had a complete lecture on that, and we covered various aspects of system sequence diagrams. And as I promised in the last lecture, that we will be looking at few more examples of system sequence diagrams. So in today's lecture we will start off with recapping what we covered in the previous lecture, and then we will revise few of the concepts that we discussed, and following that we will look at few examples of system sequence diagrams. So one very interesting question which I thought that we should discuss is that when do we need to create system sequence diagrams? If you guys remember that we discussed that normally the first thing that you create when as a requirement engineer or as a software engineer you go to gather requirements is maybe the use case diagrams. And we saw that when we discussed activity diagrams, we again asked the same question, that why do we need to create activity diagrams and when do we create activity diagrams? And the answer was pretty simple, that activity diagrams, they are used to understand or elaborate a use case diagram, because we saw that in a use case diagram we can have alternate flows. So through these activity diagrams we can represent those things. Similarly, we saw that activity diagrams, they can also be used to understand the flow or interaction between multiple use case diagrams. And the second question was that when do these activity diagrams are created? And the answer was that following, so because they are used to elaborate use case diagrams, so the ideal place would be that once we have created the use case diagrams, we can start making these activity diagrams. Now the question is that where do these system sequence diagrams fit in? The answer would be that the ideal place would be that they should be created somewhere between use case diagrams and class diagrams, or they are a bridge between use case diagrams and class diagrams, because as we saw in the previous lecture on system sequence diagrams, that a system sequence diagram, it consists of objects and the messages or the interaction between different objects. Okay, but system sequence diagram, it represents a scenario. Okay, and that scenario actually comes from the use case. Okay, so it's a bridge between the use case diagrams and the class diagrams. So ideally it should be created maybe after the class diagrams. We don't need to elaborate on the class diagram, but at least we need to know what the classes are and what the different operations of the classes are. Okay, and then the second question comes that how do we identify classes or instances? We did a similar exercise when we did our lecture on requirement engineering, and we were discussing class diagrams briefly, and we saw that there are different ways of identifying classes. Okay. And one way that we discussed is through grammatical parse. Okay, and we saw that the processing narratives or any written description of our software that is available to us, it includes the use case descriptions, the processing narratives, or maybe the scope statement. You get all of these written descriptions, and you do a grammatical parse of that. What do we mean by grammatical parse? That we try to identify the nouns, the verbs in the text. Okay. And all the nouns that we identify, they become potential classes. Now the question is that why do we call them potential classes and why we do not call them classes straight away? Because the reason is that in a written text, and these texts can consist of multiple pages, so that would mean that we might have identified 100 or 200 nouns from the text, but all those nouns, they cannot be classes in our system. So we need to filter them, and we need a criteria to say that okay, these 10 are the classes, but the remaining 90, they are not classes in our solution. Okay, and then we discussed that there are basically 6 criterions on the basis of which we either say that a noun is a class or it's not a class. The second thing is to identify the operations of the classes. And how do we do that? We again do this grammatical parse, and the verbs that we identify through this grammatical parse, the verbs which are closer to a selected class, they are made operations of that particular class. Okay, so we have the classes and we have the operations now. Okay, And now we can draw a system sequence diagram because we have all the ingredients. The only thing we need now is a initiator object, because a system sequence diagram is always initiated either through interaction, either there is always an arrow coming into a sequence diagram. We call it the initiator message. Okay, and unless and until, because a system sequence diagram, it represents a scenario. Okay, so and that scenario is started by a certain action or a certain interaction. So we need that arrow, and once that is done, then our interaction between the different objects starts. So so let's have a quick recap of system sequence diagrams, because in the last lecture we discussed various new concepts. So I wanted you guys to be very clear that how do we represent object, how do we represent the lifeline of objects, how do we represent activation boxes and stuff like that. But before we get to that, let's quickly see what we have discussed in this slide. That we know now that when do we need to create the system sequence diagrams. So it is somewhere between the use case diagrams and the class diagrams. How do we identify classes and instances? What we have covered is that we do it through basically the identification of classes and instances, that is through grammatical parse. Okay, and when we do grammatical parse, we end up with two things. We end up with nouns and we end up with verbs. Okay, and those nouns, they are also called potential classes. Okay, why do we call them potential classes? Once again, because all the nouns, they cannot be classes. So we need a selection criteria we apply that criteria, and then we end up with classes for our system. Okay, now once we have these classes, the next step is to associate the verbs as operations of these classes. So these verbs, they are basically operations, and then they are basically linked to the classes. Okay, and quickly, what was the selection criteria? We will cover that once again when we do a lecture on class diagrams. But what were those? There were basically 6 criterions. I think number 1 was retained information. Then it was, I think, multiple attributes. Then we had multiple operations, and we had essential requirements, and there were 2 more. So in all there were 6 criterions, on the basis of which we classify that whether a noun is a class or not. We will go through these criterion and how do we identify classes and such once again when we have a complete lecture on how to draw class diagrams. Okay, let's see what we will be covering in today's lecture. First of all, I will tell you what are interaction diagrams. Okay, you might have guessed that what is interaction diagram, but we will briefly see that if somebody says interaction diagram, then you should know what do they mean by that. And then we will, as I already told you, we will have a quick recap of the UML notation for system sequence diagrams, and then we will do 2 or 3 examples of system sequence diagrams. Okay, so as the name suggests, interaction diagram, it means that the diagram which represent any kind of interaction between different entities. Okay, it should represent how different entities in the system, they interact with each other. And as the slide emphasizes, that it shows how objects interact with one another. So so if you remember the system sequence diagrams, then what do we do in that? We basically have different objects, instances or classes, and then through the messages we try to identify that how these objects or these instances, they interact with each other. So basically the sequence diagrams, they are an example of interaction diagram. Another diagram that we will see, and maybe we'll start it in today's lecture or in the next lecture, they are called collaboration diagrams. They are very similar to system sequence diagrams, and they are also used to identify these interaction between different objects, and these are called collaboration diagrams. So the sequence diagrams that we are discussing today and the collaboration diagram that we will discuss in the next lecture, both of them, they are also called or also known as interaction diagrams, because they are used to represent the interaction between different objects. Okay, क्योंकि sequence diagram के अंदर हम क्या करते हैं, we identify these objects here. Object A, let's call it object of class B, or if you guys remember, we have this kind of a lifeline for each object, okay, and we have these activation boxes, and through these arrows we have messages, which are basically these messages, they are interactions. So that's why we call a sequence diagram an interaction diagram. Okay, so let's quickly go through it again. Sequence diagram, also known as interaction diagrams, semantically equivalent to collaboration diagrams. When we will cover collaboration diagrams, you would know that semantically they are the same. What do we mean by semantics? It means the meaning of them, or what they represent, is the same. Both of them, they represent interaction between different objects. Okay, but there is differences in the syntax of both these diagrams. And sequence diagram, they are dynamic model relating use cases and class diagrams. As I already said, that they are a link between use cases and class diagrams. How they are a link between use cases and class diagrams, I will elaborate on that in a bit. They illustrates how objects interact with each other. Okay, as we have already discussed in the previous slide, I gave you a small example कि आपके sequence diagram क्या बताती है कि दो objects कैसे आपस में interact करेंगे throughout their in a particular scenario. And what is the most important thing that a sequence diagram tells, apart from telling the interaction between different objects? It shows the time ordering of the messages, or time ordering of interaction between different objects. This is one of the key things that sequence diagram actually tells. Right. And generally, a set of messages between collaborating objects, and ordering of objects not significant. Or this is kind of a slight, this is related to the previous slide, because in case of the collaboration diagram, we are only interested in recording the interaction between different objects, whereas in the sequence diagrams, we want to know the time ordering of different objects. Okay, so the purpose is slightly different, because in collaboration diagram, we are only looking for the interaction, whereas in the sequence diagram we are looking for interaction, but we want to know that which interaction took place first in a particular scenario. So there is a difference. Both of them are interaction diagrams, but if somebody says that when do we need to draw sequence diagrams and when do we need to draw collaboration diagrams, so the answer is that in case you are just interested in identifying the interactions between different objects, then you need to draw collaboration diagrams. Whereas if you are also interested in knowing the time ordering, or which interaction occurs first within a scenario, so you should draw system sequence diagrams. Okay, ji. Now going back to that thing where I said that how this is a model which relates the use case and the class diagrams. How does it actually do that? Because we saw in the previous lecture that the use case descriptions, they are used to identify the classes. Okay, so they are used to identify classes. So we have the use cases and we have these classes. Okay, and why do we call it that it relates these two? Because the use cases, they basically tell us different scenarios, that how an interactor will interact with the system. Okay, whereas the classes tells us that which will be the main entities, or which will be the instances in a system. Okay, or what will be the objects that will be created in a solution in a particular scenario. So what do we do in system sequence diagram? We basically what we do is we take scenarios from use cases. Okay, and we take classes and operations from class diagrams, and for a particular scenario, then we say, okay, when a particular interaction occurs, so this will be the interaction between different objects, because the use case that only tells us the actor interaction with the system. Okay, it does not tell us that how different objects will communicate with each other. Okay, whereas a class diagram, it only tells us that how different objects will communicate with each other. Okay, it does not give a view that how an actor is involved in a particular case. So basically the system sequence diagram, it can kind of relates these two things. It is a gap, or it bridges the gap between the use cases and the class diagrams. Okay ji, so sequence diagram, they show only one flow of control, can model simple sequential flow, branching, iteration, recursion and concurrency. Okay, so through system sequence diagrams we can do multiple things. Okay, we can do a simple sequential flow, where it's, you know, an example of simple sequential flow would be that somebody logs in and he, you know, a student logs in into a student management system and he views his results. Okay, that is a very simple sequential flow. Okay, and then we can also do branching. We can have iterations. We saw example of iterations as well, and then we can have recursion, and we can also have concurrency. What other diagram that we have covered which also allows concurrent is which also allows representation of concurrent activities? That was activity diagram. Okay, and that was the key difference between activity diagram and flow diagrams, that the activity diagrams, they were a special kind of flow chart which allows representation of concurrent events. Okay, and similarly sequence diagram, we can also represent concurrency in the system sequence diagrams. And another interesting thing is that a system sequence diagram may need multiple diagrams. Okay, one we can call it primary, one we call it variant, or we can have exceptions. So for example, for a given scenario, we can have multiple system sequence diagrams, because if you remember, within a use case we have alternate course of actions, and whenever we have alternate course of actions, then what happens is that we can either draw it within the same system sequence diagram, or we can have a different system sequence diagram. I think we covered it in the last lecture as well, that if you have a very complex system sequence diagram, if a scenario involves a lot of interaction between different objects, then we can maybe break it down. Okay, and we can have multiple scenarios within a sequence diagram, or we can have different sequence diagram for different scenarios. Okay. So UML and sequence diagrams. So sequence diagram, an interaction diagram that models a single scenario executing in the system. And this line is very interesting, that this is perhaps the second most used UML diagram behind the class diagrams. Okay, now this is very interesting. When you will go in industry and you will see, this is a very interesting question which most of my students ask, that which of these diagrams are most used in the industry. Okay, and I always tell them that the class diagrams, they are always there, and the use cases, they are always there, and the sequence diagram, they are always there. Okay, because they all give you something very interesting. They all tell you something very interesting about the system. Okay, class diagram there because, you know, they give you an overview of the architecture of the system. Okay, and how different objects are related to each other. The use cases, they are helpful because they help you in identifying that how the end user or the actor would interact with the system. Similarly, the system sequence diagrams, they tell you how the objects, or in what order these objects will interact with each other. Okay, and when you are designing a system, you want to know these things. So this is something for you guys to, you know, get motivated about using these system sequence diagrams, that this is the perhaps second most used UML diagrams. Okay. We will also see that what is the relation of this diagram to other diagrams. I've already told you that they are kind of a bridge between the use cases and the class diagrams. So after use cases, you kind of draw a sequence diagrams, system sequence diagrams, and there's a concept of CRC cards. We will cover that in more detail what that is, but you know, because it's written in this slide, I will briefly tell you what they are. So CRC cards, by CRC we mean class responsibility collaborator. We already briefly covered that when we were doing the requirement engineering lectures. So by CRC we mean class responsibility collaborator. Okay, so what do we do? Once we know that we have multiple classes in our system, so we write the name of the class here. Let's say we have a class student, and we divide it into two columns. Okay, this column we call responsibility, and this column we call collaborators. So we write all the responsibilities or all the functions that a class can perform, we write them under responsibility. And if in order to perform a certain function, a class needs to collaborate with another class, so we write in front of that responsibility, we write the name of that particular class with which this class has to collaborate. So for example, if you have a student class and a student can perform, the class has multiple responsibilities. Let's say students can register using this class, they can view results. Okay. Now let's say when this class performs this registration responsibility, it cannot do it alone. It needs to collaborate with a class which is called course. Okay, because whoever student is trying to register a course, he wants to know that what is the schedule of that particular course, at what time the classes would be offered, and who will be teaching that particular course, because that would help him in deciding whether he wants to register for a certain course or not. So the responsibility registration, the student class cannot perform on its own, whereas the view results, that we are saying that in our solution it does not need to collaborate with any other class, but it can do it on its own. So the CRC card, they basically a very quick way in design of telling you that how different classes would communicate with each other, or when do they actually need to communicate with each other. And that is, I think, one of the purposes of system sequence diagrams. Okay, Ji. So what are the key parts of sequence diagrams? We have participants, an object, and how we define a participant. It's an object or entity that acts in the sequence diagram. Sequence diagram starts with an unattached found message arrow. I told you that there would always be an incoming arrow to a sequence diagram. Okay, and this found arrow, it can be attached to an actor, or it's basically some message or event coming from another system. And that particular arrow, which we call found message, it basically triggers a scenario or interaction between different objects, and that's what we try to model in system sequence diagrams. Then we have the messages. Messages are communication between participants, objects. So we have some participating instances of classes in a system sequence diagram, and through these messages we show the interaction between those objects. Now we can divide a system sequence diagram in two axes, the horizontal axis and the vertical axis. Now on the horizontal axis, we have the objects which are participating in a particular scenario, and in the vertical axis we have the time. Okay, so basically if you remember system sequence diagrams, then on this axis we have objects, okay, which are usually written in the boxes like that, and in the vertical axis we have the time, okay, which is basically represents the lifeline of each of these objects. And it also represents कि कौन सी interaction पहले हुई है, कौन सी बाद में हुई है, कौन सी इसके बाद हुई है, it's something like that. Okay, so this is these are the key parts of a system sequence diagram. Okay, ji. So let's have a quick look at what are the different things that are there in a system sequence diagrams. Okay, so as I told you that this found message, it can come from an actor as well. Okay, so this will be the initiator, okay, or we call it the unattached message, or call this the found message arrow, which will basically start the interaction between different objects. And usually, as I told you in the previous class as well, that a rectangle is used to represent an object or an instance of a particular class. And what is the syntax? We normally write the name of the object, okay, like that, and then we have these columns, and then we write name of the class or an actor. Okay, so whatever we are trying to represent, we normally do it like that. And then this dashed line under this rectangle, it represents the lifeline. So this shows that this class is active in this particular scenario starting from here till here. So this is the lifeline. And then we have these activation boxes. Okay, now this solid blue rectangle on this lifeline, this is called the activation box. And what is represented by activation box? That in a particular scenario, what was the time when this certain object or instance of a class was active. Okay, now this is the activation box. And then I told you that there are two options when we have different objects in a particular scenario. Either we create them when we need them, or we initiate all the objects at the beginning and they stay till the scenario ends. Or there is an option that we create them when we need them and we destroy them once they are no longer needed in a particular scenario. So we can do destruction, which is normally represented by a cross. And in the first scenario, where you basically draw all the objects at the beginning and you want them to be there till the scenario ends, we normally do not have this cross at the end, but you can have it when the scenario, which will basically show that at this time the lifetime of this instance of the class has ended. Okay, and then we have messages. All the messages, they should have a name. Okay, this is a must, that whenever you have a message, it should be represented, it should have a name which tells what kind of interaction is occurring between two objects. And then there is a concept of return messages, which is normally represented by this dashed arrow coming back from an object. But normally what we do is that we do not, for the obvious kind of return messages, for example, if there are two objects, okay, and we say we say from this class we send a message to this particular class and we are asking for get total. Okay, now we know that get total will return a number, so we can do that and write on it that it will return total, but we do not need to, because this is something very obvious. So return messages, they are optional. We do not normally always do them. And then there's a concept of self call in system sequence diagram, and self call, they are represented by this arrow coming back to the object. So for example, if this is the activation box and there is a self call, then we will draw another small activation box and there would be this kind of an arrow which would represent that there is a self call. So this is basically self call. This object is using some operation or something from its own class. Okay, so this is called the self class. Okay, so these are the different ingredients of system sequence diagrams. This is a very simple example, a very simple flow, that we have a student, and normally the actor classes or their instances, they can be represented by the stick figure. Okay, and in this case this class is student, and what the student is trying to do, he is trying to register a course. So we have this class and we have another class which is the scheduler, which maintains the schedule or the timetable of different courses. So what's happening here is that this class, it would have the data of the classes, okay, and this scheduler, it would have basically timetable, so of all classes, and it would also have room availability. These are the things that this would do, and the student, he can basically, what he is trying to do in this particular, so this scenario is basically registering a course. So this student, what he is trying to do is, he said to the class that I want to register for a particular class. Okay, and then this class, it basically says send a request of adjust room to scheduler. Okay, now for example, when we saying adjust room, so what it is doing then, when it comes to the scheduler, so scheduler is checking that whether the room is available. Okay, and if that is the case, so there is a self call here. Okay, so the timetable, it is checking on its own whether something is available or not, and the data is within this scheduler. Okay, so it does not need to interact with any other class. So whatever the answer is, we do not have any return messages here. So let's say it says that it is okay, and then finally we can have a return message here which says that the registration done or whatever. Okay, so we can have these optional messages, but we have not represented them here. Okay, so this was an example of a very simple system sequence diagrams, where we have a flow which represents that how students register for a particular class. Okay, G. Now there are some advanced notations when we are drawing this system sequence diagrams. We can also have the sequence number attached to a message. So whenever we are writing a message, we can have, for example, this was the arrow, and we can have something like 1.message. So this basically is the sequence number. Okay, that although the system sequence diagram is drawn in a way that we can see the time ordering, we actually know कि कौन सा message पहले गया था, लेकिन we can also, this is something optional that we can do, we can write a number, we can attach a number with the message which would tell okay, whether this message was sent first or second, or at what number this message was sent. Okay ji. Then there is a guard. Now what this guard tells, it basically says that we can have a condition with the message. Okay, so for example, there's a certain, for example, you first of all, the first thing that you want to do, if you remember in the last class we have an example where somebody was trying to issue a book from library. Okay, and the first thing in that system sequence diagram was to check whether whoever is trying to issue a book, he is the member of a library or not. Okay, and if the status was okay, then the request for borrowing a particular book was sent. Okay, so that is called guard, where you set a condition, okay, that this message will be sent if a certain condition is true. The second thing that we can have iterations. Okay, so we can say कि कितनी देर तक ये काम करना है. Again, if you remember in the last class we had an example where a driver in the bus, so the driver was actually waiting until the bus was full. So this was happening continuously, and until the bus was full, this message was not passed. Okay, and similarly we can have, so basically this represents recurrent. Okay, so basically you have an arrow coming from here, and this is called recurrent, you're calling it again, and you have your iteration here. So these are some other things. We will see some examples and we will elaborate more on these concepts. Okay ji. Now this is a very simple system sequence diagram example where we have a caller, and so the sequence or the scenario that we are trying to draw in this particular diagram is make a phone call. Okay, so and these are the objects that are involved in this. So we have this particular object, or let's say called class. This is another object or a class, and similarly this is another object or a class, and these are basically the dashed lines under every object. These are lifelines, lifeline of all of these classes. Okay, so what is the first thing that a caller would do whenever you have to make a call? आप इसको इस तरह imagine करें कि आप घर बैठे हैं, किसी को phone करने लगे हैं, ठीक है? तो what is the first thing that you would do? You will basically pick up the phone. Okay, so the caller, he picks up, and this is the message going from this to this, and the message name is it picks up. Okay, then what is the message from the phone to the caller? You hear a dial tone. Okay, and then you dial a number. ठीक है, आप दूसरा काम क्या करते हैं, आप नंबर डायल करते हैं. ओके, देन यू बेसिकली गेट अ रिंग नोटिफिकेशन. ओके, आपको एक रिंग नोटिफिकेशन आती है, यानी कि फ़ोन की तरफ से आपको दो काम होते हैं व्हेन यू डायल अ नंबर. एक तो आपको रिंग की नोटिफिकेशन आती है, और यहाँ पे अगर आप देखें तो इन जो मैसेजेस की टाइम है या किस ऑर्डरिंग में हो रहे हैं, दे आर बेसिकली डन एट द सेम टाइम, क्योंकि फ़ोन इज़ बेसिकली डूइंग टू थिंग्स. आपको रिंग टोन आ रही होती है, लेकिन जो रेसिपिएंट है हिज फोन इज़ ऑल्सो रिंगिंग. So basically it's doing two things: ring message to the recipient and the ring notification to the caller. Okay. And then what happens, as soon as the recipient picks up the phone, then there is a message from the recipient to the phone, and then you basically are in direct communication with the recipient, and it says hello to you or whatever. Okay, so we saw that this is again a very simple example, and you can do it from your real life. You can take small examples. For example, you go to the university or you attend a lecture. You can start making these very small system or very simple system sequence diagrams, and the different entities in that case would be the object. For example, your home. How when you leave the home, your car, maybe it is another class. You can draw these system sequence diagrams, and you can get familiar with these concepts. Okay, and all these are basically messages, these arrows, and we have the messages, lifeline, and the objects in this particular example. We've just seen a very simple example of system sequence diagram. As I said, okay, you can think of any simple scenarios in your normal life. For example, going to university or going to the market, and you can draw these system sequence diagrams for those scenarios, and this will give you a very quick indication okay, how simple it is. And now let's see the concept that we have discussed, that the lifespan of different objects. I told you in the previous lecture and in the start of this lecture that there are two ways that we draw the system sequence diagrams. One is that we try to identify all the objects at the beginning, and we say that the lifespan of each object is throughout the scenario. Okay, now that is a simple and very novel way of drawing system sequence diagrams. Okay, but the more advisable, or let's say a more experienced or professional way of drawing these system sequence diagrams is that you create an object when you need it, and you destroy it when you do not need a certain object in a particular scenario. Okay, so how do we do it? So when you have to create an object, you send a message which we call the create. Okay, and when you see this message going from one object to somewhere, then we mean that we are trying to create a new object or instance of a new class. Okay, so basically this creation message, what it does is, it basically this create message okay, this create message, what it does, it basically creates a new object. Okay, so when we see create, we are basically creating a new object. So at the beginning in this particular scenario, we had only this one object A. Okay, object A at the beginning. Okay, but during the interaction or during the scenario, we realized that this instance of the class A, it needs to interact with instance of class B, and we did not create that particular instance at the beginning. So what we are doing, we send a create message, and by that create message we basically create this new object. Okay, and then whatever the interaction that was required, we do that, which is basically done through this message, and then we get a return. Okay, so activation, again the activation is same. Okay, so activation box, this is the activation box, this is the same. It is symbolized by those rectangular strips and placed on the lifeline where object is activated. Rectangle also denotes when the object is deactivated. जिस तरह ये वाली rectangle यहाँ पे शुरू हुई है, इसका मतलब हो गया कि जी object activate हो गया. Okay, and at this point this activation it ends. Okay, तो अब जब end हो गई तो हमें पता लग गया कि यार इस object की तो हमें शुरू में ज़रूरत ही नहीं थी. Okay, we created it, but now we can destroy it because we do not need it anymore. Okay, so what we do is we send a deletion message. Okay, it is similar to, for example, when you used to create those pointers in C++. If you have done that, then in C++, whenever we needed it, we used to call a new. By new, we used to allocate memory to a certain variable or certain pointer, and then when we used to delete it, so we used to take it back. Okay? In other languages, for example in Java, we do not need to do deletion because it automatically does that garbage collection, whereas in C++ we used to be very explicit and we used to allocate memory, and then we used to take it back. और अगर हम उसको वापस नहीं लेते थे memory को, we didn't used to delete it, तो memory leak के problems आ जाते हैं. If you have done that programming in C++, you would know that if you do not get the memory back, or if you do not do deletion, then you get memory leaks. Okay जी. So when this activation box ends, then you basically delete, and there is no explicit message for deletion. Okay, so what normally happens is that in this particular case, it is advisable that you have this return message when this activation box ends, because this return message would tell that we do not need this object anymore. So what we are doing here, this cross at the end of this lifeline, ये आप dash line के आखिर में देखें कि ये cross है. This cross tells कि the lifespan of this particular class or this instance of this class is ended in this particular scenario here. So this is the more advisable way or more advanced way of drawing a system sequence diagram, where you basically only create an object when it is needed and you delete it when you do not need it anymore. Okay, now this is an example where you it's basically from how do we draw a system sequence diagram from the use case. Okay. Now if you see, then we have this, I told you that the customer के आपके objects होते हैं, you can represent them through these stick figures. Okay, and then you have this search page, and you have this search result page, and this catalog, and then this search results. Okay, now these symbols they are used when we do conceptual modeling. Okay, and we will have a complete lecture on that. And if you have questions that what these symbols are, then keep those in mind, and inshallah we will cover that when we do the conceptual the lecture on conceptual design, and I will tell you that what do these represent, for just so that you are not confused. These just represent the entities, okay? Few of them are external entities. External entities वो होती हैं जिनसे आपका कस्टमर इंटरेक्ट करता है, ठीक है? जिस तरह ये वाला जो सिंबल होता है, इट रिप्रेजेंट्स कि ये जो सर्च पेज है इसके साथ कौन इंटरेक्ट करेगा, इसके साथ आपका एक्टर इंटरेक्ट कर रहा है। इसी तरह जो आपका सर्च रिजल्ट पेज है वो भी एक ऐसा पेज है जिसका कि व्यू आपकी बाहर वाली एंटिटी के साथ है, ठीक है? तो उसका भी सिंबल यही है। देन यू हैव द कैटलॉग एंड द सर्च रिजल्ट्स, ठीक है? ये आपकी होती हैं जो आउटपुट होती है एक तरह की, ठीक है? दैट इज रिप्रेजेंटेड बाय दीज सिंबल्स। फिर एक और भी इसमें सिंबल होता है जिसको हम इस तरह का कहते हैं, ठीक है? ये आपका कंट्रोल को मैनेज करता है कि ये आपके बाउंड्री ऑब्जेक्ट्स हैं। ये वो वाला ऑब्जेक्ट है कि जिसके ऊपर कस्टमर ने कोई इनपुट दी, ये वो वाला जिसके ऊपर आपने कोई आउटपुट देखी, और ये वो कंट्रोल होते हैं जो कि इनके आपस में चलाते हैं। लेकिन आई डू नॉट वांट टू थिंक अबाउट दैट व्हाट दीज आर, ओके? ऑल यू गाइज नीड टू नो कि वी आर डिस्कसिंग कि हाउ डू वी ड्रॉ अ सिस्टम सीक्वेंस डायग्राम फ्रॉम अ यूज केस, ओके जी? So customer आया, and the scenario that we are trying to do here is that we are trying to search for a book, and if the book is not there, it's not found, then we display an error message कि the book is not found. If it's there, so we basically show the result to the user. Okay जी? So there is an alternate scenario and there is a normal flow. Normal flow क्या है कि आपने बुक को सर्च किया, ठीक है? और जब आपने बुक को सर्च किया तो आपको अगर वो बुक मिल गई तो यू हैव डिस्प्लेड द रिजल्ट, अगर बुक नहीं मिली तो यू शो एन एरर मैसेज, ओके जी? सो व्हाट इज हैपनिंग, कस्टमर केम इन एंड ही डज दिस ओन सर्च। सर्च के ऊपर वो आया, ओके जी? यहाँ पे कस्टमर ने भी क्या किया, ही इज ऑन द सर्च पेज एंड ही इज वैलिडेटिंग हिज सर्च क्राइटेरिया, ठीक है? सो देयर इज अ सेल्फ लूप व्हिच रिप्रेजेंट्स दैट बेसिकली इफ यू गाइस नो कि आप सर्च करने की डिफरेंट ऑप्शंस होती हैं, तो you basically enter all the, for example, you are entering the author name, the title book, or ISS and number of the book, or whatever you're trying to enter. So you basically entered that information, and if you've done search by author, तो आपने कैटलॉग में गए and you are searching it, okay जी? आपने फिर क्या किया, अपने जब आपको ऑथर के साथ अगर वो बुक मिली या नहीं मिली, ठीक है, यू हैव अ सेपरेट क्लास जिसके ऊपर आप वो रिजल्ट्स प्रिपेयर करते हैं। फॉर एग्जांपल आपने ऑथर का सरनेम डाला था, एंड विद सरनेम, विद दैट पर्टिकुलर सरनेम यू एंडेड अप विद 100 बुक्स, ओके? नाउ यू नीड टू डिस्प्ले दोज रिजल्ट्स टू द कस्टमर इन अ प्रॉपर वे। सो व्हाट यू आर डूइंग, यू आर बेसिकली क्रिएटिंग दैट पेज, ओके? जो कि यहाँ पे आपने सर्च रिजल्ट्स वाले को कहा कि एक रिपोर्ट जनरेट कर दो जिसके अंदर जितने भी ऑथर का सरनेम सेम है और जितनी भी आपको बुक्स मिली हैं इसकी एक लिस्ट प्रिपेयर कर दो। एंड वंस दैट लिस्ट इज प्रिपेयर्ड, तो you need to display it on the search result page. So that is what's happening कि search result page के ऊपर आप गए और यहाँ पर आपने वो display कर दिया, ठीक? Similarly अगर तो आपका जो search criteria है वही valid नहीं है तो वहाँ पे आपका display error message आ जाए which would say कि जी the information that you have entered it's not correct, okay? So नाउ इफ़ यू इमेजिन कि इसकी यूज़ केस डायग्राम कैसी होगी, ठीक है? यानी कि इसकी सिंपल सी यूज़ केस डायग्राम ऐसी है कि देयर इज़ अ कस्टमर, ठीक है? और अगर हम उसकी सिस्टम बाउंड्री बना दें ऐसी, ठीक है? तो कस्टमर क्या कर रहा है, बेसिकली ही कैन सर्च, ठीक है? कस्टमर सर्च करता है किसी बुक के लिए, ठीक है? और फिर कस्टमर, अच्छा, अब ये जो सर्च है, इस सर्च के अंदर बहुत से काम हो रहे हैं, ठीक है? एंड दैट इज़ व्हाट वी आर डिस्प्लेइंग। ये हमने जो पूरा सिनेरियो है ये हमें देखें हम उसको कितना एलेबोरेट कर रहे हैं कि कस्टमर जब एक चीज़ को सर्च कर रहा है तो ही इज़ डूइंग एक्चुअली सो मेनी थिंग्स, देयर आर सो मेनी ऑब्जेक्ट्स व्हिच आर एक्चुअली इंटरेक्टिंग हियर, ठीक है? यानी कि कस्टमर्स इंटरेक्शन इज विद ओनली द सर्च पेज, ओके? वेयर एज और कस्टमर क्या करता है, अपने व्यू करता है रिजल्ट्स को, ठीक है? वट एवर द रिजल्ट्स आर, ठीक है? अगर उसकी सर्च का क्राइटेरिया वैलिड नहीं है तो एक एरर मैसेज डिस्प्ले हो रहा है, अगर बुक्स मिल गई हैं तो पूरा डिस्प्ले उसको आदत है कि क्या क्या चीज़ें मिली है, ओके? सो दिस इज द यूज केस एंड दिस इज द सीक्वेंस डायग्राम फॉर दैट पर्टिकुलर यूज केस, ओके जी? दिस स्लाइड इट जस्ट सेज कि हमने पिछली स्लाइड के अंदर देखा था कि वी सेंड अ क्रिएट मैसेज वेयर एज वी कैन ऑल्सो सेंड दिस न्यू, ठीक है? ये न्यू उसी तरह जिस तरह हमने क्रिएट था कि वी आर जस्ट क्रिएटिंग दिस न्यू मैसेज। जैसे एन एग्जाम्पल कि हम रियल लाइफ के अंदर हमें इसकी कब ज़रूरत पड़ सकती है, ठीक है? अच्छा, सो वी हैव अ हैंडलर हियर, ठीक है? और वी हैव अ क्वेरी कमांड हियर एंड वी हैव अ डेटाबेस स्टेटमेंट, ठीक है? आपने जब भी किसी यूज़र ने दिस वी कॉल दिस, हम इसको क्या हमने कहा था, इसका नाम दिया था, वी गेव इट द नेम फाउंड मैसेज, ठीक है? तो क्वेरी आई डेटाबेस के पास, ठीक है? आपने एक न्यू ऑब्जेक्ट इसका क्रिएट कर दिया क्वेरी कमांड का, ठीक है? अब हो क्या रहा है कि इसने न्यू क्रिएट कर दिया डाटाबेस स्टेटमेंट, ठीक है। अब इसने फिर एग्जीक्यूशन की रिक्वेस्ट भेजी इसको, उसको उसके रिजल्ट्स मिले, ठीक है। जब इसके पास रिजल्ट्स आए तो उसने वो एक्सट्रैक्ट किए रिजल्ट्स और यहाँ से एक क्लोज का मैसेज भेज दिया इसको। क्लोज का क्या मतलब हुआ कि डाटाबेस की स्टेटमेंट अब बंद हो गई है और हमें इस ऑब्जेक्ट की जरूरत नहीं रही, तो वी हैव डिलीटेड दैट पर्टिकुलर ऑब्जेक्ट, ठीक है। सिमिलरली यहाँ पे जब क्वेरी कमांड से इसके पास भी रिजल्ट्स आ गए हैं तो इसने यहाँ से इसको रिजल्ट्स वापस भेज दिए और ये वाला ऑब्जेक्ट भी डिलीट कर दिया, ठीक है। तो दैट इज द सेम थिंग दैट वी हैव डिस्कस्ड विद क्रिएट एंड विद डिलीशन, बट देयर आर टू थिंग्स न्यू हियर। दैट पहली बात तो ये कि हम जब नया ऑब्जेक्ट या नया इंस्टेंस क्रिएट कर रहे हैं तो वी आर सेंडिंग दिस न्यू, हम न्यू के साथ क्रिएट कर रहे हैं। एंड सिमिलरली वी आर सेंडिंग दिस क्लोज, जिसका मतलब क्या है कि अगले ऑब्जेक्ट को आप डिलीट कर दो, ओके। सो दिस इज द सेम एग्जांपल और द सेम थिंग दैट वी ऑलरेडी डिस्कस्ड। Okay जी, representing something about representing objects, and then we're moving towards the examples for system sequence diagrams. I told you that the objects, they are represented with squares and they are optionally preceded by the object name and the colon. Write object name if it clarifies the diagram. Okay, this is something for you to keep in mind कि if in a particular scenario आपका ऑब्जेक्ट का नाम लिखने से आपकी डायग्राम का सिनेरियो it becomes more clear, then you do that. Otherwise you can just write the class name and that would be it. Okay, then we have the objects live line which is represented by a dashed vertical line, जो कि हम बहुत दफ़ा डिस्कस कर चुके हैं, ठीक है। अब ये जो है ये हमारा ऑब्जेक्ट है, ठीक है, और ये पेशेंट है, ठीक है जी। अब इसके अंदर दिस इज एन ऑब्जेक्ट जिसके ये क्लास पेशेंट है और इसके अंदर हमने ऑब्जेक्ट का नाम भी लिख दिया, ठीक है। सो वी नो व्हाट द ऑब्जेक्ट इज, whereas okay, this is an example of the object जिसके अंदर हमारे पास class है, we write the name of the object, name of the object इस केस के अंदर क्या है, Smith, whereas इसके अंदर we have not done that, we have just written the name of the class patient, so we call this anonymous object, okay जी। और this is another thing, ठीक है, इसके अंदर हमने क्या किया, we have just written the object, we did not write the name of the class, okay जी। तो we can also do that, लेकिन हम इसको कहेंगे object of unknown class, हमें अब इसकी class का ही नहीं पता, ठीक है। But this is not ideal, ठीक है। So we should not do this, but this is right, we can do that and we can do that, okay। क्योंकि इसके अंदर हमने क्या किया, हमने बहुत स्पेसिफाई कर दिया, हमने ऑब्जेक्ट का नाम भी बता दिया इस सिनेरियो के अंदर और हमने क्लास का नाम भी बताया। इसके अंदर हमने सिर्फ क्लास का नाम बताया है, लेकिन हमने ये नहीं बताया, हमने कहा कि दिस इज एन एनोनिमस ऑब्जेक्ट, वेयर एज इन दिस केस हमने सिर्फ ऑब्जेक्ट लिख दिया और हमने क्लास बताई नहीं है, ठीक है जी। ओके Okay, just a quick recap of the messages. Message or the method calls between different objects. It is indicated by this horizontal arrow to other objects, जो कि हम already बार-बार देख चुके हैं. What we do is we write the message name and the arguments above arrow. यानी कि एक message के साथ, this is the message name, we can have these arguments. ठीक है, हम उसके साथ arguments को भी attach कर सकते हैं and then we send it to another object. Okay जी. और जिस तरह हमने कहा था कि रिटर्न मैसेजेस दे आर ऑप्शनल, और रिटर्न मैसेजेस किस तरह शो करते हैं, बाय दीज डैश्ड एरोस, ठीक है। और नॉर्मली वी हैव डिफरेंट एरो हेड्स, ठीक है, जो सॉलिड एरो हेड्स होते हैं, ठीक है, जो नॉर्मल मैसेजेस होते हैं, ठीक है। अच्छा, वन स्लाइड डिफरेंस कि जो आपके एसिंक्रोनस मैसेजेस होते हैं, ठीक है, एसिंक्रोनस मैसेजेस का जो नॉर्मली एरोहेड होता है वो इस तरह का होता है, ठीक है। दिस इज समथिंग दैट वी डिस्कस इन द लास्ट लेक्चर कि यू कैन पास डिफरेंट काइंड ऑफ मैसेजेस बिटवीन डिफरेंट ऑब्जेक्ट्स. सम मैसेजेस आर सिंक्रोनस एंड सम आर asynchronous. Okay, whenever there is a synchronous call from one object to the other object, तो it means it's a blocking call. जब आपका कॉलर है जिसने synchronous मैसेज भेजा है, it would not be able to do anything until it gets the result back. Whereas in case of asynchronous call, he sends the message and then he can send more messages. Okay, so you can have asynchronous calls within a system sequence diagrams. Okay ji. Now first of all, let's do a quick example of a customer who is trying to withdraw cash from an ATM. Okay, so our example is, or a scenario that we are trying to model here is system sequence diagram for withdrawing cash from an ATM. Okay. Now, what are the classes or what are the different entities that would be involved in this communication? If you must have used those ATM machines. So, what do normally you do? You basically, you as a customer, you go at the ATM. Okay, so you're standing in front of an ATM. The first thing that you do is you enter your PIN number. Okay, so that is the first interaction between you and the ATM. So once you have entered the PIN number, then the ATM, it needs to confirm that whether the PIN that you have entered is correct or not. So maybe a message is sent from an ATM to the bank, and when the bank says, okay, this was the card number and that's the PIN, if they match, so there will be a message coming back to the ATM, okay, which would say, can you display the different options to the user, okay. एंड देन व्हाट हैपन्स, जब आप एटीएम के अंदर पिन डालते हैं, आपका पिन सही होता है, तो आपके पास एक नया मेन्यू आ जाता है, ठीक है. एंड इन दैट मेन्यू यू कैन डू मल्टीपल थिंग्स, ठीक है. यू कैन आइदर व्यू योर बैलेंस, यू कैन आइदर transfer your funds, you can withdraw cash, and you can do multiple things, okay. But if the pin that you entered it was wrong, so you get the result which would say कि जी आपने जो अपनी पिन डाली थी that was incorrect and you need to enter it again. Okay, and in each case, for example, let's say you decide to draw with cash. Okay, again आप cash की request ATM पे भेजते हैं, but there would be an authentication message to the bank, जिसमें बैंक के पास वो जाके चेक करेगा, यार इसने जो authentication की मेरे पास अब बात की है, इसके पास बैलेंस भी है इतना. If the user has balance more than a certain amount, तो that certain transaction would be allowed. If the balance is not there, of this balance is, if the cash request or the withdrawal request that you have sent to the ATM, for example, आपने कहा जी 10,000 निकाल दो, आपके अकाउंट में 5,000 पड़ा है, तो that particular interaction it would not occur, ठीक है. So that is conditional in the case of this particular scenario. Okay जी, so let's see हमारा इसके में क्या बनेगा कि we have this customer जो कि basically हम हैं, ठीक है, और हम कहते हैं कि जी ये इसकी लाइफलाइन है. Okay, and then we have this ATM machine जिसको हम कहते हैं, ठीक है, and then we have this bank. Okay, ओके जी. अब ये कस्टमर ने क्या किया, कस्टमर ने ATM को ऊपर आया और कस्टमर ने कहा कि जी एंटर्स पिन, ठीक है जी. अब जब आपने अपनी पिन इसके अंदर एंटर किया, तो एज वी डिस्कस्ड व्हाट दिस वुड डू, दिस वुड सेंड अ मैसेज टू द बैंक टू कंफर्म कि जो आपने पिन एंटर की है वो सही भी है कि गलत है, ठीक है. नाउ दिस शुड कम बैक विद अ रिटर्न मैसेज व्हिच शुड आइदर से ओके और नॉट ओके, ठीक है, यानी कि अगर पिन सही है, ठीक है. एंड देन ATM डिस्प्लेज, कस्टमर के पास अब क्या जा रहा है, कस्टमर के पास जा रहा है display result, ठीक है. either he will get the new menu or he would basically enter that pin again, ठीक है जी. okay, now this is just one scenario कि अगर आप पिन एंटर कर रहे हैं और आपने एक सिनेरियो बना दिया. the other thing would be that कस्टमर इसके बाद रिक्वेस्ट करता है withdraw cash करने की. okay, so let's say the customer says that I want to withdraw certain amount of cash. okay, now when you do that, तो again ATM के पास तो आपने कैश की रिक्वेस्ट भेज दी, लेकिन ATM does not know how much balance do you have. तो ATM से फिर एक रिक्वेस्ट जाएगी बैंक के पास, जहाँ पे ATM से क्या हो रहा है, इंक्वायर बैलेंस, ठीक. अब ये पूरे कस्टमर का एक सेशन मेंटेन हुआ है, ठीक है. बैलेंस इंक्वायर किया, इफ बैलेंस वॉज सफिशिएंट तो द कैश इज विथड्रॉन एंड कैश कस्टमर के पास चला गया, ठीक है. और इफ यू वांट टू डू अनदर ट्रांजैक्शन देन यू वुड डू इट, और इफ यू वांट टू एंड योर सेशन तो यू वुड से, कस्टमर से इसको मैसेज आ जाएगा नो फर्दर ट्रांजैक्शन, और यहाँ पे आपका ये वाली पूरा सीक्वेंस ख़त्म हो गया. ओके, लेकिन इसके अंदर कुछ चीज़ें हैं, जिस तरह हमारा जो ये वाला सारा काम हो रहा है, ये जो इंक्वायर बैलेंस से लेके और ये जो कैश विड्रॉल वाला काम हो रहा है, दिस ऑल थिंग इज कंडीशनल, ठीक है. इसकी कंडीशन क्या है कि इफ कस्टमर रिक्वेस्ट फॉर कैश इज लेस देन कस्टमर बैलेंस, तो तब ये वाला काम होगा, ये पूरे का पूरा काम उस वक्त होगा. अगर ये नहीं है तो ये वाला काम नहीं होगा. नॉर्मली इन अ सिस्टम सीक्वेंस डायग्राम्स इफ यू हैव दीज कंडीशंस, ठीक है, और इफ यू हैव सेट ऑफ इंटरेक्शंस जो कि सिर्फ एक सर्टेन कंडीशन के ऊपर आप करते हैं, तो यू कैन रिप्रेजेंट इट थ्रू दिस बॉक्स. ठीक है, तो आप ये ऑप्शनल एक बॉक्स बना देते हैं जो कि रिप्रेजेंट करता है कि ये वाला काम सिर्फ उस वक्त होगा जब ये वाली कंडीशन सही होगी. ओके, सो यू कैन डू दैट विद इन अ सिस्टम सीक्वेंस डायग्राम. ओके जी, लेट्स हैव अ लुक एट अनदर एग्जांपल. ठीक है, लेट्स ट्राई टू मेक एन एग्जांपल फॉर that human resource management solution which we used to discuss which we discussed in our okay, and let's say the scenario that we are trying to make here is that the HR manager is asking for monthly report. Okay ji. So what's happening here is, okay, here you have your HR manager, ठीक है, and here is maybe your system, ठीक है, okay, and let's say you call, यहाँ पे हम कहते हैं हमारा रिपोर्टिंग सिस्टम है, ठीक है, और ये हमारे पीछे बैक एंड पे जो हमारा डाटा पड़ा हुआ है उसके पास जाता है. ओके, सो व्हाट इज हैपनिंग हियर कि आपका HR मैनेजर आया, ठीक है, और HR मैनेजर आके कहता है जी आई वांट टू, इनफैक्ट व्हाट वी शुड डू इज, हम एक काम करते हैं कि वी विल मेक इट वी विल क्रिएट इट व्हेन वी नीड इट. ठीक है, उस तरह से बनाते हैं बिकॉज दैट वुड बी इंटरेस्टिंग दैन. ओके जी, सो हम पहले करते हैं कि जब HR मैनेजर ने लॉग इन कर लिया तो वी सेंड इट अ क्रिएट रिक्वेस्ट टू दिस ऑब्जेक्ट जो कि इसने क्रिएट कर लिया, एक ऑब्जेक्ट रिपोर्टिंग सिस्टम का. ठीक है, जब इसने ये ऑब्जेक्ट क्रिएट किया तो अगला काम क्या कर रहा है, ये इसे कहता है जी आई वांट टू, बेसिकली यहाँ पे अब ये क्या काम कर रहा है, ये मंथली रिपोर्ट जनरेट करना चाह रहा है. ठीक है, अब यहाँ पे क्या हो रहा है, बेसिकली यहाँ पे पहले वो इसको वैलिडेट कर रहा है, वैलिडेट द रिपोर्ट ऑप्शंस. ठीक है, अगर उसने सही रिपोर्ट ऑप्शन डाली है कि नहीं डाली. व्हेन इट्स डन दैट, तो यहाँ से क्या होगा, देयर विल बी बेसिकली अ मैसेज गोइंग. यहाँ पे फिर हम कहते हैं कि जी क्रिएट करो. अब हम क्या क्रिएट करा रहे हैं, यहाँ पे हम क्रिएट करा रहे हैं अपना जो भी हमारा डाटाबेस का हमने जल्दी से एक क्वेरी हैंडलर क्रिएट करवाया. और यहाँ पे अब हमने फिर एक मैसेज क्या पास कर दिया, द नेक्स्ट मैसेज वुड बी, एक मैसेज आ रहा है जो कि हमारी रिपोर्ट रिक्वेस्ट है जो कि हमने एक क्वेरी की फॉर्म में भेजी है इसे. इसने जब उसको वो रिजल्ट्स मिले, इट विल बेसिकली सेंड दोज, दिस शुड ऑल बी वन बिग. ठीक है, ओके, यहाँ से क्या है, the resulting report is basically, this is the dashed arrow जो कि इसके पास आ गया. और when this activation box end, तो we have a crosshair. ये क्रॉस हमें क्या बता रहा है कि हमने जो डाटाबेस का एक इंस्टेंस क्रिएट किया था जो भी क्वेरी हैंडलर, वी डू नॉट नीड इट एनी मोर. इसी तरह जब हमारे पास रिपोर्टिंग सिस्टम ने रिजल्ट्स दे दिए तो वी सेंड दीज रिजल्ट्स बैक टू दी HR मैनेजर, और हम इसको भी ख़त्म कर रहे हैं. यानी कि HR मैनेजर अभी चल रहा है, लेकिन जो हमारे ये दो ऑब्जेक्ट्स थे, ये वाला यहाँ पे क्रिएट हुआ और ये वाला यहाँ पे क्रिएट हुआ, फिर ऐसे हमारा ये वाला ऑब्जेक्ट स्टार्ट से क्रिएट हुआ था. ठीक, अगेन इसके अंदर भी हमारी अगर कुछ कंडीशंस है and there are certain interactions between objects which would only happen in a particular case, so we will not make them. Okay, now let's try and do another very quick example, which a portion of it which you already saw. That let's say we are trying, our system is a patient management system where we have patients, and what they do, they are trying to book an appointment with a doctor, and they want to know what's the schedule of the doctor, and then they basically decide, okay, then we'll basically do it. So हम कहते हैं जी हमारा एक तो हमारा patient का एक ऑब्जेक्ट है और एक क्लास. ठीक है, then we have our central system जिसके ऊपर हमारा सारा डाटा वेयर है ऑथेंटिकेशन के लिए. Then we have डॉक्टर क्लास, और फिर डॉक्टर, हर डॉक्टर से एसोसिएटेड उसका एक स्केड्यूल भी है. ओके जी, अब जो पेशेंट का ऑब्जेक्ट है, लेट्स से क्योंकि पेशेंट जिसके अंदर आपका सारा काम कर रहा है तो हम कहते हैं जी पेशेंट जो है वो ज़्यादा देर तक एक्टिव है, ठीक है। सबसे पहले पेशेंट आता है, वो अपने आके यहाँ पे लॉगिन की रिक्वेस्ट कर रहा है, ठीक है। लॉगिन किया, अगर तो वो एग्जिस्ट करता है तो लॉगिन सक्सेसफुल है, अदरवाइज यू नो ही विल ट्राई अगेन, ठीक है। लॉगिन उसने अगेन किया, अगर तो सक्सेसफुल हो गया तो अब कस्टमर क्या कर रहा है, कस्टमर ने सिस्टम से कहा कि जी मुझे एक डॉक्टर के साथ अपॉइंटमेंट बुक करनी है, ठीक है। इसने क्या किया, इसने जो डॉक्टर का आपके ऑलरेडी क्लास एग्जिस्ट करती है, हमने शुरू से बना दिया उसका लाइफ स्पैन, उसने इसको रिक्वेस्ट भेजी कि भाई मुझे इस पर्टिकुलर डॉक्टर के लिए, जिस तरह मैसेज आया कि अपॉइंटमेंट और इसका पैरामीटर क्या है, शायद डॉक्टर की आईडी, इस डॉक्टर के लिए अपॉइंटमेंट चाहिए मुझे, ठीक है। और आपका दूसरा पैरामीटर क्या हो सकता है, टाइम, किस टाइम के ऊपर चाहिए। अब यहाँ पे इसने एक नया हमने क्रिएट की रिक्वेस्ट भेजी जो कि हमारा स्केड्यूल था, जिसके अंदर पूरा स्केड्यूल पड़ा हुआ है, क्रिएट किया। अब इसको हमने कहा कि जी जो ये पर्टिकुलर टाइम था इसको हम मैसेज भेज रहे हैं चेक अवेलेबिलिटी, ठीक है। और हमने इसका पैरामीटर क्या दे दिया, टाइम। अब ये अवेलेबिलिटी बता रहा है कि इस टाइम के ऊपर ये डॉक्टर अवेलेबल है भी कि नहीं है। अगर तो डॉक्टर अवेलेबल है तो यहाँ से हमारे पास इस तरह जैसे काम खत्म हो गया एक्टिवेशन बॉक्स, यहाँ पे हमने क्रॉस लगा दिया कि इस सब्जेक्ट की हमें ज़रूरत नहीं है। यहाँ से एक रिटर्न मैसेज आ गया जिसने बता दिया अवेलेबिलिटी का रिजल्ट, ठीक है। और वो हमने वापस भेज दिया पेशेंट को, अगर तो वो अवेलेबल है पेशेंट को चला गया और पेशेंट ने अपॉइंटमेंट बुक करा दी और पेशेंट को उसका रिजल्ट भी चला गया। अगेन दीज आर अगेन वेरी सिंपल सिनेरियोस, ठीक है। And what I would suggest that if you want to practice more on system sequence diagrams, then think of very simple scenarios as I already suggested, and try to identify the different objects in those scenarios and try to record interactions between them, and then you will get more familiar with these system sequence diagrams. Okay, that's now we are coming towards the end of our lecture for today. And let's have a quick summary of the contents that we have covered in today's lecture. This lecture was revision or elaboration on the system sequence diagrams that we discussed in the previous lecture as well. So we saw in our revision सबसे पहले कि system sequence diagrams कहाँ पे fit होती हैं, where do we need to draw these system sequence diagrams. So the answer was that they relate the use case diagrams and the class diagrams, ठीक है। क्योंकि use case diagrams हमें क्या बताते हैं, interaction बताते हैं, ऑब्जेक्ट जो आउटसाइड एक्टर्स हमारे सिस्टम के साथ इंटरेक्ट कैसे करते हैं, ठीक है। और जो हमारी क्लासेस होती हैं वो बताती हैं, पहली बात तो वो बताती हैं कि क्लासेस कौन सी है, हर क्लास के कौन से ऑपरेशंस हैं और क्लासेस कैसे करती हैं। लेकिन एक पर्टिकुलर सिनेरियो हमें यूज केस से मिलता है और क्लासेस हमें क्लास डायग्राम से मिलती हैं। फिर हम ये जब सिस्टम सीक्वेंस डायग्राम्स बनाते हैं तो इट टेल्स अस कि हाउ डिफरेंट ऑब्जेक्ट्स दे इंटरेक्ट विद ईच अदर, ओके। देन वी सॉ द डिफरेंट एंटिटीज दैट आर देयर इन द सिस्टम सीक्वेंस डायग्राम्स। उसके अंदर हमने देखा हमारे पास क्या क्या होता है, वी हैव दोज ऑब्जेक्ट्स, ठीक है। ऑब्जेक्ट्स होते हैं और सबसे पहले एक फाउंड मैसेज होता है जिसके बगैर हम नहीं कर सकते। देन वी हैव दोज ऑब्जेक्ट्स और क्लासेस होती है हमारे पास, ठीक है, विच आर ऑन द हॉरिजॉन्टल एक्सेस। देन ऑन द वर्टिकल एक्सेस we have the time and we do basically send these interactions between different objects जो कि आप देख सकते हैं, ओके जी। and then we saw कि we can also create and delete objects when they are needed and when they are no longer needed we delete them, okay. whereas the other way is कि आप सारे object का life span throughout the scenario बना दें, ठीक है। Then we saw कि we can have these conditions and loops in our system sequence diagrams, जो कि मैंने आपको आखिरी एग्जांपल के अंदर भी बताया था कि we can have these conditions और ये condition को हम ये एक बॉक्स ऑप्शनल बॉक्स से शो कर सकते हैं कि this would happen if a certain condition is true, ठीक है, and that scenario would not happen if it's not true. फिर हमने देखा कि हमने मैसेज को डिफरेंट तरह से एनोटेट कर सकते हैं। वी कैन हैव द पैरामीटर्स इन अ मैसेज। मैसेज के अंदर सबसे जरूरी चीज़ क्या है, मैसेज नंबर। उसके साथ हम सीक्वेंस नंबर भी अटैच कर सकते हैं। फिर हम गार्ड अटैच कर सकते हैं विच इज़ अ कंडीशन कि ऑन अ सर्टेन कंडीशन दिस मैसेज विल बी पास्ड। देन वी हैव द मैसेज नेम। फिर हम मैसेज के साथ आइटरेशन भी कर सकते हैं, आइटरेशन एसोसिएट कि ये मैसेज कितनी देर तक आइटरेट करेगा। देन वी कैन हैव द लिस्ट ऑफ पैरामीटर्स विद इन अ मैसेज। देन वी डिड दोज एग्जाम्पल्स जिसके अंदर हमने एक HR वाले M की एग्जाम्पल की, ह्यूमन रिसोर्स मैनेजमेंट सोल्यूशन की, फिर एक पेशेंट की बुकिंग अपॉइंटमेंट के सिनेरियो की एग्जाम्पल की, फिर एक अपने एग्जाम्पल की विड्रॉ कैश की। आई थिंक दैट इज इट फॉर टुडेज लेक्चर एंड until next time, take care and Assalamu alaikum.